Okay. Can everybody see my screen? Mo, my screen online there?
Good, William, keep going.
Okay, great. So today's webinar is about virtual storage arrays, and it's a term that it's like, you know, a lot of terms in storage. New terms get created all the time with good reason because we have evolving use cases. But I think it's one of those terms where when I go to shows, I find that people use it in one way and not always in the same way that we would use it. So I'd like to share with you today some reflections on that. So in this, you know, there are, as I said, there are many different new categories of storage, you know, converged storage, SDS storage, virtual storage array networks, and what is the relationship of all these different types of storage one to the other. So hopefully today we're going to shed some light. It might be an empty store light, but we are going to try and shed some light exactly on what these terms mean. So one of the use cases where you might want to have, or where you might want to virtualize storage is when we look at the cloud. I think everybody understands the issues in the cloud of software-defined storage and how software-defined storage can provision to virtual machines within the cloud. And I think that use case is well understood, or it's relatively well understood. But what about all the stuff that's under the cloud? You know, how do you virtualize the storage arrays themselves to be able to provision to other consumers of storage which are not just virtual machines? So that's one of the issues where virtual storage arrays can help. Certainly software-defined storage controllers are very good at automating the provisioning of storage to virtual machines, especially when coupled with, you know, high-level dashboards such as Horizon dashboards. But what happens when within an actual tenant space somebody needs a lot more control over the storage than what a classical dashboard would give them? So again, this is another area where virtual storage arrays can be very useful. So a definition, you might want to mute everybody. Mo, you might want to mute everybody because we're getting some chatter back from some of the attendees. So a VSA definition, how we define it is, it's the virtualization of a storage array in a data center space or a tenant space, a virtual machine tenant space. And that can be a KVM OpenStack tenant space or a VMware tenant space, makes no difference. And then storage array as a service is really the whole management framework around VSAs. So having a VSA image to launch in the tenant space is useful, but if we have a whole VSA appliance which says I can take a high-end, high-spec appliance which may be running, you know, many different media tiers with many different fabric backends, how can I virtualize that into a whole bunch of virtual storage arrays and provision, use those virtual storage arrays to provision the undercloud? So here is how we would conceive of a virtual storage array itself. So a virtual storage array itself consumes some storage on the back end. Typically it should be block storage, and typically the VSA, if possible, needs to be connected to that block end storage over, you know, pretty high-speed fabric. Or it could be back-ended by object storage if you're trying to export on the other side of the VSA storage that isn't time critical. But the key point is that in the VSA you're not just provisioning a storage volume to your virtual machines. I've shown here OpenStack VMs, but I mean it can be anything. You're not just provisioning storage to those VSAs. Your virtual storage array within that tenant space will also bring along with it and provide snapshot, thin provisioning, replication, encryption, deduplication, all of the features that are associated with the VSA. The only difference between that and something that's on a physical server is, of course, it's running in your tenant space and it's running virtualized. All the services that it offers are dragged along because it's software, and then it's not connected to a high-speed backplane. It's connected over a high-speed bus to something that's providing it with with the storage. So that's how we conceive of a virtual storage array. And then storage array as a service would be the ability within a tenant space to drop in one or more storage arrays, provision those virtual instances within your tenant space with real storage over, it could be over, you know, a gig bus or a 10 gig or 40 gig or fiber channel, whatever the fabric management you have within your data center. That storage can be provisioned from a back end to your virtual storage arrays, and those storage arrays themselves, through their own management tool, can provision out volumes to your virtual machines that are within your system. And some of the things that you can do with that virtual storage array technology that you maybe couldn't do with a dashboard is, for example, create storage that be connected to multiple machines and shared with multiple machines. Also, the storage can be exported over iSCSI, CIFS, NFS. So in your tenant space, you may have a range of different virtual machines, and the storage can be exported through that virtual storage array over whatever protocol your machine wants to consume it at. Also, if you have two different virtual storage arrays which are back-ended by different types of fabrics and different types of storage media, then those virtual storage arrays themselves will be able to provide volumes at different SLA and QoSs. So that's what we mean storage array as a service. It's a managed framework to manage your VSAs, and for those VSAs then to be dropped into tenant networks. Or those virtual storage arrays themselves can be exported within a data center space, either tunneled or flat, into whatever type of machine wants to consume that storage. So just if we look at a bigger picture of that storage array as a service, the elements of it would be some sort of a provisioning dashboard which would provision storage to the VSAs, and then the VSAs themselves will be able to provision out to all of the virtual machines. And the important point here is that this VSA now has a much more advanced dashboard than you would traditionally find in a self-service provisioning dashboard, because this VSA has all of the standard storage services like snapshot, then provisioning, replication, encryption, etc. And it can export its storage within that tenant space over iSCSI, CIFS, NFS, or indeed object storage. And we can contrast that to the slightly different view of storage as a service. So this is the view of storage being provisioned through a dashboard such as a Horizon dashboard or a VMware dashboard, where I'm provisioning volumes and then I'm provisioning those volumes directly to my virtual machines. So I don't have an entity in my tenant space which is being provisioned to and then re-provisioning out. So that's the main difference between storage as a service, which is the classic way today within a dashboard / software-defined storage controller system of provisioning virtual machines, and the previous way of storage array as a service. And the advantages are, of course, that you have a much more control over your storage provisioning and management using virtual storage arrays and storage arrays as a service. So if you look at how we consume storage, and you know, I've just put up a couple of names here, and this will probably resonate with the attendees, is that, you know, if you look at storage services and cost effectiveness, and I do agree it's a little bit arbitrary by what we mean by cost effectiveness, but I think with some justification we can say that if you say cost effectiveness as a TCO number as distinct from the ROI of any particular storage system, then proprietary physical storage arrays from all of our tier 1 storage providers tend to provide very high levels of storage services. So without doubt, these machines provide very high levels of storage services. But if we compare them to something like an OpenStack environment, then we have to say that from a cost effectiveness viewpoint, the physical storage arrays, even though they give very high storage services, are not as cost effective along this line here. If we look at along this line as well in terms of cost effectiveness, you can see that storage services, there are some storage services in, for example, OpenStack, VMware, through the standard dashboards that we get from them. But they tend to be typically provision this virtual machine with this amount of storage. They don't drag along with it all of the storage services. So whilst we can say that they have good cost effectiveness, they don't have a very high level of storage services. Now there are some projects within OpenStack, for example, Manila, which is file service as a service. Running a Linux VM itself as a file server is another way of having a storage service, and you can even run things like FreeNAS as virtual machines. But if we want to have that high level of storage services that a professional IT administrator would like to have within his tenant space, then he needs to be up along this line. And there are some VSA type technologies. I mean, VMware has a product called VSA, though I'm not sure it would be exactly the same class as this. But other companies like Nutanix, Scale.io have elements of their technology which we can consider as virtual storage array technology. What MP-Store is proposing, or what we'd like to show you today, is more in line, I suppose, with what Zadara is showing, which gives you very high levels of storage and services, but it's up on that high curve of cost effectiveness, much better than what you would have from physical storage arrays. And the answer, and the reason why it's quite simple, is that your virtual storage array has, from the software viewpoint, it has all of the capabilities to do snapshot, tin provisioning, replication, exports over different network protocols, but it's typically back-ended by open platform hardware, and that's where there's a significant cost advantage. Also, there's probably a significant cost advantage in the way VSA technology is itself priced. It's priced in a manner where it's a lot better than physical proprietary physical storage arrays. So, in the end, why would anybody, what's the issue surrounding storage? Well, one of the main issues is that users really want to have a storage that is configured appropriately for it to work with its with the workload that it's trying to run. So every time that we provision storage, we need to consider that storage is provisioned from some sort of a performance tier, with some sort of capacity. And in order to get or cover all of the points on this graph, all of the different performance tiers and all the different capacities, you need a range of tools. And part of those tools is the tool of the virtual storage array, because it's provisioning all of the consumers of storage can't be done simply with just one tool. It can't be done simply with just a proprietary standalone hardware storage array. It can't be done with a software-defined storage enhanced dashboard, and it can't be uniquely done with a virtual storage array. You need to have a range of tools to be able to cover all of the points on the graph. So before we start getting into a demonstration of, and make this a little bit more concrete, if we look at the two types of users of storage in a data center, the first type of guy is someone who says, look, I want storage of a particular category and a particular category and a particular QoS, and he can use his dashboard to he can use something like an OpenStack dashboard to. One second, I just need to kill narrations on this thing here. Okay, we're good to go again. Apologies, guys. I just had a little narration on that, which was causing me a problem. So in this particular case, an end user can use a high-level dashboard. He really doesn't want to be troubled by any of the infrastructure organization, and as long as he has policy-driven provisioning of the storage, he's going to get the storage at the right tier that he wants. However, there is another class of user which is he needs a lot more control. He needs to be able to manage his policy. He needs to be able to say, look, I need to provision storage, not just capacity, but I'd like to manage my own snapshot policy, my own thin provisioning, my own replication strategy, my own deduplication, my own compression, etc. And I'd like to export it over different protocols such as NFS or CIFS or iSCSI, and I'd like to set up, clustered virtual storage arrays, and I would like to have storage shared between systems. So all of this more advanced, having a lot more control. This is in that data point on the graph where the admin of that tenant space needs a lot more control. So when we look at, the final, before we look at some demonstrations here, when we look at the final configuration of how all of these components fit, we can say that at the base end, it's always the same. And we need to have a whole bunch of different storage providers, and those storage providers themselves have got to be able to do all of the things that a storage array does. But typically, these are all part of the undercloud. They're not. We can't wire a portion of this storage array directly into a tenant space. So our storage providers is the framework upon which we're going to build everything on top of. And then in terms of who are the storage consumers, we can identify, well, the usual suspects. Virtual machines are the obvious consumer of storage that most storage frameworks today are provisioning up to, virtual machines. So whether it's an OpenStack, VMware, whatever cloud environment you have, then provisioning to virtual machines is one of the standard things that we can do. But then you need to consider, well, what happens about storage services? What type of a framework do I need for that? Bare metal provisioning up to different storage nodes. So these are other categories of consumers of storage in the data center. And then finally, within a tenant space, can I drop in a virtual storage array and have that storage array wired down to my storage providers? And can I connect that storage over, can I back-end that storage over whatever fabrics I have configured in my data center and over whatever protocol? So provisioning object storage up to this virtual storage array might be considered one tier. Provisioning SSD from one of these storage arrays over some high-spec SAN to this virtual storage array could be considered another tier. So these are the points in the provisioning map that we want to try and provision to. Virtual machines, that is a method that we all understand, and virtual storage arrays are a way of provisioning storage directly into the tenant space. So that's the top level part of the presentation. So what we'd like to do now is we'd like to take you through some demonstration of systems that we have up and running here, and hope by going through the by going through the actual demonstration, it'll make this a little bit clearer. Okay, so the first use case that I'm going to look at is the use case of a virtual storage array appliance. So earlier on we said that a virtual storage, storage array as a service, in this case encapsulated as an appliance, means that I have to have a range of, I need to be able to virtualize the actual storage array itself. So if I launch, I'm connected here to a virtual storage array appliance. If I launch the dashboard for this, okay, I'm using OpenStack itself to run a bunch of images which themselves are storage arrays. So here I'm actually running, I'll just change the view here. So in this view here, we can see that this machine, which is a physical machine, is actually exporting 5 virtual storage arrays. And if I connect to any one of these storage arrays, it will just appear as a storage array. I can provision from it. I have all the storage features that I would have on a physical array. So let me just connect to any one of these here. Are any of these actually up and running yet? Or pick any one?
Yeah.
Okay. So I'm now going to log into a machine which is running a number of virtual machines, and each virtual machine is itself a virtual storage array. So, is it capital A?
No.
Oops.
No, it's capital A on the username.
Oh, I'm in caps lock. Apologies. So what I'm looking at here is a VSA. So this VSA provides me all of the functionality that I would expect in a storage array. So one of the things I'd expect in the storage array is to have disks attached to it. And here I have a number of disks, but in fact, the disks that are attached to it are VirtIO disks. So these disks are provisioned to this VSA by our overall storage array appliance. So here are my disks. They have been attached from a downstream storage controller, and typically you can run the VSA instances actually on the same machine that has the storage volumes. You get much higher performance, but it's not necessarily required. I can simply create a RAID. So I have a RAID here that's created, and on top of that, I can create volumes. So if this was running in my tenant space, I might say I want to create a volume, pick a size. I can have all the access to all of the storage array type functionality and build it on top of a RAID and continue on and export it. Obviously, this is a virtual storage array, so I can't export it on physical ports. I can just export it on an Ethernet port, but I can choose whether I want to export it over sys, NFS, protocol, and then whatever hosts I have configured in my system, I can export it to those. So this is an example of a virtual storage array running as a virtual machine with very tight coupling to back-end storage. And then, as we mentioned earlier on, once I've created and exported those volumes, then I have access to all of the standard functionality such as snapshotting, replication, a various amount of tools for doing backup of my volumes, etc. So I have all of the standard storage array functionality encapsulated in this VM, tightly coupled to the back end with my storage. So that's the first use case of how we would use a storage array. The next use case, and these virtual storage arrays themselves can form part of the provisioning network within the within your cloud. So if you imagine a data center which requires where you might have some very high-speed media, a bunch of disks on a very powerful machine with lots of cores, then running a number of virtual storage arrays connected to different media types allows you to provision out that storage array, that full-featured storage array, to whatever consumer you want in the data center, and that can actually be in a flat space. So you're provisioning into people who might be in some co-located space, or it could be tunneled inside of a virtual machine framework. Now, the next use case is exactly that. I'm going to connect to another. I'm going to connect to another machine, which is here is our cloud controller. So this is this is not the virtual storage array appliance. I'm now just going to look at a tenant space, and in my tenant space here I have 3 Windows machines. I'm just going to use Windows as an example. It's probably a little bit easier to illustrate the point. And in this tenant space, I'm also running a VSA appliance. And that VSA appliance is now, all of these machines here can access the storage as presented by this VSA appliance. And this VSA appliance, if I log into it, and I just pick its
The one on the bottom.
on the bottom. If I just pick this IP address here, if I log into this machine here, so once I've logged into this machine, so this machine is now running within our tenant space. I can see that this machine itself is provisioned with storage volumes. And again, they're VirtIO. Now, there are different options, and the volumes can be provisioned as block or SCSI, but in this particular demonstration, we're just using block. So just hold that thought there. I now have this virtual storage array. It's provisioned with storage volumes, and the question is, how did we provision this virtual appliance with the volumes? Well, simply if I go and look at my volumes, I can see now I've created 3 different volumes which I've attached to my VSA appliance. So if I go back to my that's how I provisioned my storage array in the first place. So then back here, if I now look at my volumes that I have created in that system, we can see that I've actually created a number of LUNs, and these LUNs have been exported to my Windows machines, and they've been exported as iSCSI.
2 of them as iSCSI.
Okay, so the first one, if I look at my volume, okay, and if I look at my port mapping or my host mapping, if I look at my port mapping, I can see that it's exported over the SIPS protocol. And if I look at the other 2 volumes, I can see that I've exported those over an iSCSI protocol. So now what we've demonstrated is that sitting within your tenant space, your virtual storage array can be provisioned with storage from some back-end system, and we can have a look at the back-end system in a second, and then that storage array can then re-provision out to the various storage arrays. So just to show you that we are indeed consuming that storage on those storage arrays, I'm just going to log in here. Just bear with me 1 second. So,
It's on the CIF export already.
okay, so if I look here at my if I look here at my virtual machine, I'm now logged into one of those virtual machines, the 131. So we can see here that the storage that I have, one of those SIPs volumes.
That's on the previous folder.
Okay, in the previous folder.
Thanks a little bit. So here we are on the Windows share, on the fifth share, sorry, from Windows.
So this is the share that we've exported to the virtual storage array, and we can now use this as a normal storage array. I use this as a normal volume. This is connected as a SIFS volume. If I log into 130.131, I'll see the storage exported and imported as a nice SCSI volume. The advantage of provisioning this way to your virtual machines is that obviously the administrator who has access to this virtual storage array can set up all of his own snapshot replication, tin provisioning, cloud backup strategies for those volumes that have been exported to the VMs in his tenant space. So I think that as an overview of how we can launch a virtual storage array appliance within a tenant space, use it to provision out to the VMs in that tenant space, and then use the features of that VSA appliance. That is, we have now demonstrated how you can do that and the type of components that you need to use. That's the instance of launching a VSA appliance within a tenant space. And then the other use case is if we look at virtual storage arrays that are not within the tenant space but are in the data center space, how they can be used to provision real physical machines, or in a co-location environment, give a co-location customer their own slice of a virtual storage array. So that's our presentation today. If there are any questions, we'll gladly answer them.
William, thank you very much. Thank you very much, everybody, for being on this webinar. There are a couple of questions, William, that came in. The first one is, what's the use case of VSA versus VSA appliance? And I think what I mean is, where do you need to use the virtual storage array, and where do you need to use the virtual storage array appliance?
Well, okay, so a virtual storage array itself is a particular machine image. So you could, and I don't think you can, but if you could actually take a VSA image and just drop it into Amazon, and within your tenant space within Amazon, you could use your virtual storage array to provision your VMs. The VSA appliance itself is quite different because it is a whole framework for managing. It's a whole framework for managing virtual storage arrays. So in a virtual storage array appliance, it would be typically used by the data center itself as a way of virtualizing its own storage and providing a virtualized part of any particular storage array to its own tenants. So there's kind of one is an image and the other is a whole framework for managing all those images in a coherent way. Does that answer the question?
Yeah, I think it covers the. I have another question here. Virtual storage array model. Can I consume any type of storage? Can I mix and match? And the second question, which is related to this, which is how do I manage different tiers of storage and how do I add them to the VSA or the virtual storage array. So they're both about the tiers of storage that you can consume in.
Well, I think that question, for example, can you use mix and match different types of media is a good one. So I'll give you an example of a working. This is a working configuration that NP Store has a white paper on, well, or soon to be released white paper, which shows how two storage arrays can be connected together using the features of a VSA. So a VSA is an entity, it's a storage array. It is able to do things like replication. It is able to do things like backup to an object store. So why not configure them in a particular way? And let me just walk you through this as an example configuration for disaster recovery, which is a pretty novel configuration, and it explains how all of those different media works. So if you imagine I have a standard space, and I OpenStack configuration, and I launch my virtual machine, but I launch it with the within a storage volume. Then I can quite simply snapshot that volume. I now have a complete perfect snapshot image of my virtual machine, attach it to my VSA, and then back that up to another VSA who is actually back-ended with an object store. And then at some stage, if this whole cloud on the right-hand side dies, I can just rehydrate my volume and launch my VM again. And so that's an example of how to implement disaster recovery between two tenant spaces managed by the same tenant, and where the volumes on one side are replicated from whatever block storage they are over here to an object store over here, and then within that tenant space they can be rehydrated back to another volume and restarted again. So this is an example of where, as to answer your question, can I mix and match and have different storage backends and different media? The answer is of course. Storage arrays, by the very definition and nature, are entities that are able to consume storage from different backends and export it over different fabrics and protocols to whoever wants to consume it. So does that answer your question? What was the second question?
It was how do I manage different tiers of storage, and how do I add the storage into the virtual storage array?
Okay. Okay, so one way of looking at that is that's typically a function. That's typically a function of your within the data center of your SDS controller. So I suppose there are two components to that. So one part of that component is within an entity like a software-defined storage controller. Oh, sorry. Sorry, my screen was paused there. So there are two parts to the answer to that question, Mo. So the first part is, how does the data center within its own software-defined storage controller setup, how do they manage the media tiers? Well, within the NP Store SDS controller, and I would imagine it would be the same for other storage controllers, you can create the concept of different storage groups. And this concept of the storage group is something that's going to be exposed back up to your provisioning dashboard. So if I look here at a storage group called archive storage, and if I look at archive, I've actually, those storage arrays that we looked at earlier on, I actually dropped all of those virtual storage arrays into a storage group called archive. And I can keep using this tool to put different storage arrays of different types and different media tiers into these storage groups. All of those storage groups will then be presented back up to my provisioning dashboard. So that's the first part of the answer, or the first answer to the first part of the question. How do I physically manage all my back-end stuff? Well, simply put your storage arrays into different storage groups And for every storage array that you put in there, make sure that you've created a policy that will use to the best extent that storage. So if you have, for example, a storage array and it's solid state disk, then you probably want to say that that storage array should behave according to a policy of a high-speed tier, for example. That's the first part of the question. And then the second part of the question is, if you then go to your dashboard, and how would the end user then benefit? How would the end user benefit? I should be on 10, the wrong one. How would the end user benefit from all those different media tiers? Well, then, quite simply, when he goes to create a volume, he now has access to whatever storage groups which themselves map to different media tiers. He can then pick it up here. So he can then say, look, I want a particular storage size, fair enough, but I want it from a particular storage group. And that different storage group will correspond to different policies, which will have different media tiers and different fabrics on the back end. So that answers the second part of the problem. So one is, how does the data center manage its media tiers? And then the second part is, how is that exposed or exported to the end user? And it's exported through the concept of storage groups and compute groups.
Yeah, I think that covers it, William. I have another question here about security, and how do you control security in a virtual storage array? What's the mechanism, and does it have security, from what I'm reading?
Well, obviously, a virtual storage array is going to sit within a tenant space. So a virtual storage array is sitting within the isolated tunneled tenant space of the tenant. So from that viewpoint, once it's inside the tenant space, then part of the answer is, how secure is my tenant space? So tenant space security is all about setting up the correct rules so that anybody who accesses my tenant space, only authorized people can get into it. So that's the first part of the problem. And all of that is managed within an OpenStack environment. There are other environments do it differently, but in the OpenStack environment, there is access and security frameworks to make sure that only certain machines can be accessed by other machines. So the first thing we can do is we can set up a VSA security group, which says within that group, the only people who can access this storage array are the following IPs, and they would be the IP addresses of the particular virtual machines that we've configured in our storage array. So that's the first way. We can set up firewall rules around the virtual storage array to make sure that no one can access it except the no one can access the volumes that it exports except through the firewall. That's the first part of this of the answer. The second part of the answer is that when we add within the storage array itself a tenant or somebody who's going to access the storage array volumes, then we can use all of the standard iSCSI or CIFS or NSS type protection, such as setting our host IQN, setting chat passwords or username passwords for the users when they're going to log in to our storage array. So it is a secure system. One of the tenant space itself is protected. It's in a tunnel tenant space, and if you don't give your virtual storage array a public IP, no one is going to be able to get it. And then the users which use it, i.e. your virtual machines, they themselves have got to have their own username, password, IQN, and the firewall rules then make sure that no one else can access that virtual machine except what the administrator has configured to be able to do it. So I think that answers some of the issues around security and access control of a VSA. Do we have any other questions, Mo?
Yeah, one more question. The storage array as a service model, how does it fit in today's data center?
I think well, that's a very good question. So I definitely hope that was a serious one from the audience. But I think that if you go to data centers today tend to be of kind of two. They tend to be of kind of two types. So we can imagine type A data center offers co-location as a service. And they really are saying, here's my data center, I want to get an Amazon, I want to get a rack space, I want to get a big tenant in here, and once that anchor tenant is in there, they can be the provider of all virtualized services to all of the second level people who come in. That's kind of one data center model, and I think that data center model is kind of dying, and I don't think that the virtual storage array as a technology or storage array as a service fits into that model. However, I think that data centers today are frequently realizing that not everybody's going to have an Amazon or rack space or a big anchor tenant. That in fact they do need to attract in those thousands of new companies who need not just rack space or co-location space, but need to be able to go in and say, give me I want to use your physical services, but I also need your virtual services. So once people start asking data centers to provide them with virtual services, then you need to ask, well, what are the virtual services that the data center needs to supply? And there, storage array as a service does become a very important part of the services that a data center can offer. Because in this case, they can offer not only compute and storage as a service through standard frameworks such as VMware or standard frameworks such as OpenStack, but they can also take their hardware, build half a rack of storage, run a virtual storage array appliance and configure it as a virtual storage array appliance, and then virtualize out half a dozen disks, 50 disks, 10 disks, whatever storage capacity they need for that storage array, and then provide that to their customers and say, here you are guys, here is a storage array dimensioned to whatever capacity you need with all of the storage array services running on it, but they don't have to physically get a storage array and put it in the rack. They're just virtualizing a part of a large array of disks in a rack. So in that regard, I think that virtual storage array or storage array as a service represents to the data centers a new service offering, a new type of service that they can offer their customers above and beyond power, above and beyond rack space, above and beyond networking. So I think in the evolving, in those advanced or those data centers that are evolving to offering virtualized services, I think it's an important component of the services that they can offer.
Thank you, William. Last question. You mentioned Zadara and you put it in the same quadrant as MP Store. What's the competitive advantage of MP Store over Zadara or compared to Zadara?
So MP Store, like Zadara, has a VSA image. So, in that regard, you can sit down and you can compare, feature for feature, snapshot, thin provisioning, replication, dedupe, encryption, etc. So these are all the features of one storage array against another, and perhaps one is better than the other. But where MP Store is different than Zadara is that if we go back to our demonstration, what we actually showed you was the virtual storage array appliance itself. So here in this system here, on this machine here, we have taken a high-spec machine. It happens to be an Intel machine, back-ended by a whole bunch of SSD disks and some spinning media, and we've run a number of virtual storage arrays, and each of those storage arrays can be consumed by whatever consumer in the data center we want to give it to. So Zadara has the VSA image, but they don't have the virtual storage array the whole management of multiple storage arrays. So in that regard, MP Store is different. We have not only the MP Store, not only the virtual storage array appliance, but equally the virtual storage array image, which can run in KVM, VMware, in this virtual storage array appliance. So it covers a good many more use cases than Zudara would. That's a principle difference.
Thank you very much, William. I think that's it for the questions. Thank you very much, everybody, for joining this webinar session. If you have any questions, you can send them to mo@mpstore.com. If you would like an in-depth webinar on our software and how you can use it, you can connect, send me an email, and we'll get you set up for our dedicated webinars. Thanks again. The webinar will be available online shortly after this session, and we'll send the link to everybody. Thank you very much.
Thanks, Paul.